Hello there. Another video here, and we're looking at more straight line graph work. In fact, we're looking at how to graphically solve simultaneous equations, and we're going to look at one example and one example only, how to solve this equation here. Well, how do you start? Well, first we'll label an equation 1 and equation 2. Now the problem here is we've got to solve it graphically. I can't do it algebraically, so I have to draw the graph of each of these. But the big problem is they're not in the form of y equals mx plus c. So my first step is to rearrange them so that we've got y as the subject. So for equation 1, I move the x across, so I get 2y equals minus x plus 8. Notice I put the minus x in front. I know intuitively it should go afterwards, but we want it in the form of y equals some number times x plus c. I haven't got y equals some number in front of x plus a number. I've got 2y, so I've got to divide everything by 2. So it's minus a half x plus 4. So that's equation 1. And now, what about equation 2? That's a bit easier, isn't it? All I have to do is move this 3x to the right. So I get y is equal to minus 3x. Notice I put it in the front again, plus 9. Now, what does that mean? Well, the numbers in front of x are the gradients, if you recall from some of the earlier videos, and the number added on or subtracted is called the y-intercept, where it crosses the y-axis. So let's plot those graphs. So let's remind ourselves, equation 1 was y equals minus a half x. God, I've got a memory like a goldfish. Minus a half x plus 4. And the second one was y equals minus 3x. I think it was plus 9. Let's double check. You know, the memory's getting better. Now we're going to draw those graphs. Let's draw the graph of equation 1. So the number added on is plus 4, so that's where I start my plotting. And the gradient is minus a half. That means every time I go across 1, I go down a half. Or better still, every time I go across 2, I go down 1. So that's my second point. And you only need 2 points to draw a straight line. So I'm going to join these up. I'm going to try and join them up. And then extend the line, because I don't know where the other line is going to go. And that's the graph of equation 1. Now, the graph of equation 2. The number added on was plus 9. So I go to plus 9. And the gradient is minus 3. So every time I go across 1, I go up minus 3. Which in everyday language is down 3. So I go across 1 and down 3. Now let's try and join these points up. Now, where do they cross? They cross here. They cross where x is 2 and where y is, let's roll across, where y is 3. And let's just double check algebraically in equation 1. Actually, let's not bother with that then. and we actually have the solution. X is 2 and y is 3. If I go back to my original, get rid of all this gubbins. I could do that with a single press. I've got my solution. Suggested solution is x equals 2 and y equals 3. So let's double check with equation 1 is 2 plus 2 times 3 equal to 8. It is. What about equation 2? Is 3 times 2 add 3 equal to 9. It is. And there we have it. And that's the way, you know, if you have to do it graphically, go and double check algebraically as well that your solutions make sense. Okay, thank you for listening. Bye.